this is where we had reached in our last video. Now, what we want to do is look at this integral here. And we're going to find the integral along a curve, taking three different routes from one point to another, alright? And see what the results will be. Let me see something here. I want some space to work. Alright, I'll just go with this. So here now, what we want to do is to evaluate this integral between the point 0, 0 and the point 2, 4. Say part A, we go along y equals x squared. In B, we'll go along y equals 2x. And in C, we'll go along 0, 0 to 0, 4. Then, well, maybe I should say from 0, 0 to 0, 4. Then from, say from 0, 4 to 2, 4. Alright. So, let's do the integral along these and see what will happen. But, just to get an idea what the roots would look like, if you go from 0, 0 to what was it again? 2, 4. So this is 2 and this is 4. So about right here along x squared, it would look somewhat like this, alright? This is x squared. If you go along 2x, 2 2 is 4, yeah, it will be a straight line from here to here. This is 2x. And the third option is to go up from 0, 0 to 0, 4. Then go across from 0 to 4 to 2, 4. Alright? So, we'll be going upwards like this and then across. So we go this way and then this way. And put the arrows on them. Alright, so we can go this way, we can go this way, or we can go up and then across. Alright? So let's see what's going to happen here. Part A. Now here you see integral of 3x squared y squared dx. So the integral along the curve of 3x squared y squared dx plus 2x cubed y. Oh, this bracket should put it around the dy. Alright, right. What is it? 2x cubed y dy. Alright. 2x cubed y dy. And remember that in the previous video I showed this to be an exact differential. Alright. So I expect that regardless of the route that you take, you should get the same results. Alright, so this is going along y equal x squared. We're going along y equal x squared. Now remember, when we're doing this line integral, we want everything as in terms of x dx. We're going to have to change the y. Y equal x squared. So what we have is the integral along the curve of 3x squared. Well, if y is x squared, and we have y squared, then what we would have here is x squared. Y is x squared. Squared dx plus 2x squared. And then we have y, which is x squared dy. But as I said, we don't want to have any dy's, so we're going to have to change that dy. You see this y equal x squared? When you have y equals x squared, if we differentiate this to find dy by dx, what we're going to have is 2x. So therefore what we have is that dy is equal to 2x dx. So we know what dy is, so we can change it now. So let's rewrite this thing and say the integral along the curve of 3x squared, well, x squared squared is x to the 4th dx plus 2, well, here we have x squared. Is it x squared? No, x cubed is x cubed, my mistake. It should be x cubed. Right. 2x cubed y, which is 2x cubed x squared. So what we have here is 2x to the 5th dy, but dy is 2x dx. Okay, good. So we're putting it together bit by bit. Now we have the integral along the curve of 3x, well, x to the 4th, and this x squared would be x to the 6th dx plus, now you have 2 times 2, which is 4, x to the 5 times x would be x to the 6th dx. See that? Alright, so, well, what we really have here is the integral along the curve of 3x to the 6 plus 4x to the 6 is 7x to the 6 dx. Right, so it's well condensed. Now, since we're moving along x, the first x was 0 and the other x was 0 and the other x is 2. So we're really integrating from 0 to 2. We're going from x equals 0 to x equals 2, right? So we can put it on the integral sign instead of just the c. So we're integrating from 0 to 2 of 7x to the 6 dx. What will this give us now? With 7x to the 7 over 7 from 0 to 2, which will be, substitute 2 is 7 times 2 to the 7 over 7 minus 0 now 7 times 0 to the 7 over 7. But this part, you know that it will be 0. What we have here is 7 by 2 to the 7. 2 to the 7 is what? 2 2 is 4, 4 2 is 8, 8 2 is 16, 16 2 is 32, 32 2 is 64, 64. 128. There is 128. The 7 will cancel 7, right? So this amounts to 2 to the 7, which is 128. So you get 128 for this. Alright. Let's look at part B now. I know that will soon be running, well, running out of scrolling space already. So let's draw a line upwards and work on this side of the line. Let's do that here. Alright, so again, have the integral along the curve of 3x squared y squared. Let's write that down again. We have integral along the curve of 3x squared y squared dx. So it's 3x squared y squared dx plus 2x cubed y dy plus 2x cubed y dy. Alright, and this is part B we're doing now, right? Where was it again? Along 2x. So this will go along 2x. Alright, so let's see what's going on here. Well, I should say along y equals 2x. So let me put it properly. Along y equals 2x. Alright. So if y is 2x, dy by dx is equal to 2. So therefore, dy is equal to 2 dx. I want to fix that up from now, because I know we're going to have to change the dy. So you're integrating along the curve of 3x squared y squared. Y is 2x, so it's 2x squared dx plus. So remember, we want to change everything to x and dx. We're going to have numbers, x's and dx, alright? No y's and no dy's. So here you have 2x cubed y. Y is 2x, so we say 2x times dy. But dy is 2 dx. So it's 2 dx. You see what's going on there? So you integrate along the curve of, simplify these things now, 3x squared, 2 squared is 4, x squared dx plus, I have 2 by 2 by 2, is 2 2's 4, 4 2's 8, x cubed by x to the 4th, dx, alright, integrate all of this, and that is equal to integral along the curve of 3 4's 12, x to the 4th dx plus 8 x to the 4th dx equals, alright, so this will be what, 8, 12 and 8, that's 20 x to the 4th dx. We're integrating, but where are we integrating from and to what again? From x equals 0 to x equals 2. So we're going from 0 to 2 of this. So this is 20, oh my, it's 20 x to the 5th over 5 from 0 to 2. This gives us what now? 20 into 5 into 20, 5 into 5, 1, 5 into 24, 4. Alright, let's write it this way first. It's 20 times 2 to the 5th over 5 minus 20 times 0 to the 5th over 5. So what do we get now? This 2 2's, well, 5 into 5, 1, 5 into 24, 4 times, what is 2 to the 5th? 2 2's 4, 4 2's 8, 8 2's 16, 2 2's 32. 32 minus, well, you know, this part will be 0. That is 20 times 0 over 5, which is 0. 4 by 32 is what? 4 2's 8, 4 3's 12, 128. We get 128 again. Same thing. Alright? That's part B. Let's look at part C now. For part C, from 0, 0 to 0, 4. Alright. From 0, 0 to 0, 4. So we're going from here to here. 0, 0 to 0, 4. We're going straight up. Now, if we're going straight up, alright, first of all, let me rewrite integral along the curve of 3x squared y squared dx. So, we're finding the integral along a curve of 3x squared y squared dx plus 2x cubed y dy. 2x cubed y dy. Alright. If we do this, we go straight up. There's no change in x. So dx is equal to 0. And the fact is, x remain at one value. Alright, so let me write it this way. X will be 0. Because you find starting at the origin and go straight up. So it's the line x equals 0. Because you're going straight along the y-axis. So it's x equals 0. Now dx, you did not shift left or right. So the change in x is 0. So dx is 0. Alright. So here now, you're integrating along the curve of, well, 3 times 0 squared y dx. But dx is also 0. So this part will be 0 plus. Alright. So in this case, we have integral going up from, let me just check something, make sure everything is okay. Yeah, we're going up from 0 straight up. So x is 0, so it's 2 times 0 cubed y dy. So everything amounts to 0. The integral along the curve of 0 plus 0. So if we do this, we get 0. Alright, so no change, going straight up. Now we're going from 0, 4 to what again? 0, 4 to 2, 4. What will happen? From 0, 4 to 2, 4. Alright, so remember we had this. Then we go straight across. This is from 0, 4 to 2, 4. What will happen there? Alright. But remember, this is a straight line. It's supposed to be straight. Let me redraw this thing here. So we go up and then we go across. Alright. So this is what we're concentrating on now. Now what would happen in that case? As we go along, we see that y remains at one number. If you plot the graph, you see that you are here at 4 and you go straight across. So y is 4. Alright? Now you can see that dy, when you move straight across, there is no movement up or down, it's just straight. So the change in y, changing the horizontal, the vertical was 0. So dy is 0. Alright? So what we have here is the integral along the curve of 3x squared y squared, which is 4 squared dx plus 2x cubed times y, which is 4, times dy, which is 0. Right? So this part would be 0. So what you have is the integral along the curve of 3x squared. Well, with the 3 it would change. This is 4 squared. 4, 4 is 16. And then 16 times 3. So if we have 16 by 3, 3, 6, 18, bring down the 8, carry 1, 3, 1, 3, 1, 4, 48. So this will be 48, right? So it's 48x squared dx. This part is 0, because you multiply by 0. Now, where are you going? From where to where? You're going from x equals 0 to x equals 2. So you integrate from 0 to 2 of 48x squared dx, which will be 48x cubed over 3 from 0 to 2. So this gives you what now? 2 2's 4, 4 2's. Alright, let's substitute the values. 48 times 2 cubed over 3 minus 48, oh boy, 48 times 0 cubed over 3 should amount to 0. So what you have is 48 times 2, 2, 4, 4, 2 is 8 over 3. This gives you 3 no 3, 1. 3 into 4 goes 1 time on 1. 16. Alright. 3 is 18, 3, 1, 3, 4. So 3 into 48 is 16. 16 times 8 is what? 16 times 8. 8, 6, 48. Bring down the 8, carry 4. 8, 1, 8, 9, 10, 11, 12. So you have 128 as the answer. Right? You have 128. That's what we got for B. And that's what you got for A. So as you see, it doesn't matter the route that you take from one point to the other. Alright? If you go along this curve, or you go along a straight line, or you go straight up and straight across, it will give you the same answer as long as the function is an exact differential.